Hello. Hello. Good morning. Good morning to everyone. Today we are going to discuss the important concept of unit number 1 matrices. And the topic which I am taking today is called quadratic form to canonical form. Okay, how we are going to convert a quadratic form to canonical form, and from that, how to find out index, signature, order, nature, everything I will tell you. For that one, let me go for some rough discussion. What I am going to discuss today, that is called quadratic form to canonical form. It means instead of matrix, one quadratic equation will be given in our question. That one we have to convert to the canonical form. So some of the steps are involved here. First, I will write the steps, and after that, I will erase it all. Step number 1 is a quadratic form will be given. Like for example, x square plus 2y square plus z square plus 2xz. One quadratic form will be given that I'll discuss. This one we have to convert into matrix form, and from the matrix we have to find out characteristic equation, that is magnitude of a minus lambda I value. That will be equating to 0. You will get your eigenvalues. Eigenvalues. Okay. And now, if the order of the matrix is 3, you will get 3 eigenvalues. And for each eigenvalue, there exists at least one eigenvector. Today, what I am discussing, that is called non-repeated eigenvalues. Non-repeated eigenvalue. After getting eigenvalues, you will get some eigenvectors. Take those eigenvectors and form another matrix. That is called model matrix P. Okay. Then for this one, we have to find out normalized eigenvectors. Normalized eigenvector. And we have to find out transpose of this P. After that, finally, when you are going to simplify this, you will get your matrix, diagonal matrix will be like that. Whatever the eigenvalues, you will get it, that is in diagonal, and rest of all the elements must be 0. So, okay, this is a rough idea. Then let us see the problem. You will get the complete idea. I'm taking the question now. The question is important question. You may get it. This question point to point. Reduce the quadratic form. I'm using the short form as QF. Quadratic form, that is 3x square plus 5y square okay. Yeah, any student is there outside? Plus 3z square, 3x square plus 5y square plus 3z square minus 2xy minus 2yz plus 2xz. Okay. So 3x square plus 5y square plus 3z square minus 2xy minus 2yz plus 2xz. 2 canonical form. To canonical form. Sometimes your question will be stopped here only. That's it. He's asking to reduce quadratic form to canonical form. But this question some extra. By orthogonal transformation. By orthogonal transformation. And hence find rank, comma, index, comma, signature, and nature. So one question only we can do today. This question is not only one question. Quadratic form to canonical form is one part of the question. Checking that orthogonal transformation is the second type in this question. And finding the rank and index, signature and nature is the third part of this problem. So one problem itself will take a lot of time. So have a patience. Okay. Let us start. Okay, Namrata, your student is not there, your friend.
No, she's not there.
Solution. Given quadratic form is, whatever the question given, that we have to write down as it is, 3x square plus 5y square plus 3 z square minus 2 xy minus 2 yz plus 2 xz. This is your quadratic form which is given in our question. Now this one I want to convert the matrix. Let us take that matrix will be equal to A. Now be careful, look at that how I am taking this converting work. The square terms should come in diagonal. 3, 5, 3. Always write down the square terms in diagonal. Okay. Now xy, give it x to 1, y to 2, and z to 3. x1 means it is the position of the element lies in first row and second column. Similarly, second row and first column. First row, second column, second row, first column. Dividing with 2 always. First row, second column is here. Second row, first column is here. So dividing with 2 means you will get it minus 1 and minus. This is 2, 3. Y stands for 2. Z stands for 3. So second row, third column, third row, second column. Here, again dividing with 2, we get minus 1, minus. First row, second column, second row, first column. Second row, third column, third row, second. This. And this one also, first row, third column, third row, first column. Again dividing with 2, you'll get your answer is 1 and 1. This is a matrix. 2 marks question also it is possible. Simply it is given quadratic form and asking to convert into matrix form. Or we can say that it is symmetric form. Quadratic form to symmetric form. 1 2 marks question is done. I repeat once again, quadratic form to symmetric form. This is done. But our question is not this much. We have to convert it to canonical form. So look at the order, 3 rows and 3 columns. It means when we are finding the eigenvalues, you will get definitely 3 eigenvalues. It may or may not be repeated. That is not our target. But the eigenvalues should be 3 because the order of the matrix is 3. Now find out the.
Sir, why are we dividing it by 2, sir?
That is the rule. to get the matrix always for first row and second, whatever it is. If it is 1 year also, year 5 also, we will get 5 by 2. That is the rule. Square term should come in the diagonal, and xy coefficients or yz coefficient xy and yx. That is first row, second column, always dividing with 2. To make a matrix form, we have to divide with 2. That is the rule. Okay. The characteristic equation is, otherwise you have to memorize one formula. I don't want to make you in trouble. एक formula याद कर लेना पड़ता फिर आपको वो, that is a lengthy formula. Why unnecessary? Just dividing with 2, you will get the matrix. The characteristic equation is, we know that it is magnitude of A minus lambda I is equal to 0. This implies that magnitude of A minus lambda I already told that there is a change in diagonal only. This is 3 minus lambda, minus 1, plus 1, minus 1. This is 5 minus lambda. This is minus 1. This is 1. This is minus 1. This is 3 minus lambda. And this is equating to 0. And if you simplify, you will get the lambda values. Those values are called what? Eigenvalues. अच्छा, ये मैं आपका एक क्वेश्चन है, आइगन वैल्यूज मैं डायरेक्ट लिख दूं या आपको करके बता दूं पूरा? टेल मी. Plus, minus, plus. Come on, tell me. Should I write eigenvalues directly, or we should simplify this one to get the eigenvalues?
We will simplify, sir.
Okay, let us do it. This implies that 3 minus lambda, corresponding column and row neglected. We get 5 minus lambda into 3 minus lambda, AD. This is AD. Minus into minus plus 1, 1 is 1. Close it. Second element, minus into minus plus 1. And again column and row we neglect. Minus 1 into 3 minus lambda. Minus into minus plus AD minus BC. Plus 1 into, again column and row we neglect. AD means minus into minus plus 1. Minus 1 into 5 minus lambda. Equated to 0. After simplifying this one, we get the values of lambda. 3 minus lambda into, we shall multiply this one, 5 3 is 15, minus 5 lambda, minus 3 lambda, minus into minus plus lambda square, minus 1, plus 1 into, this is minus 3, minus into minus plus 3 lambda, no, sorry, lambda only, plus 1, plus 1 into 1 minus 5, minus into minus plus lambda 1 is a lambda is equal to 0. This implies that 3 minus lambda as it is. This one, if you simplify, lambda square minus 5 and 3 together becomes 8 lambda. 15 minus 1 is 14. Okay, you have to check again with me also. हो सकता है मेरे से भी कोई mistake. This is lambda. 1, if you multiply, you will get same thing. You will get it here. Lambda minus 2. Lambda minus 2. Minus 3 plus 1. Plus 1 into lambda. 1 minus 5 is minus 4. Is equal to 0. This implies that 3 multiplying with each and every element, that is 3 lambda square minus 8 3 is 24 lambda, 14 3 is 42 minus lambda cube, minus into minus plus lambda 8 lambda square minus 14 lambda plus lambda, what is a lambda, minus 2 plus lambda minus 4 is equal to 0. Now, one of the verification is always you will get lambda cube term is negative. Yes, we are getting lambda cube negative. Now, 8 plus 3, 11 lambda square. That is correct. 11 lambda square is correct. Now, how many lambdas are there? You can see from this one. You have to use for this one calculator. That is minus 24, minus 24, minus 14, plus 2. Your answer will be minus 36 lambda. Now, how many constant terms you are getting? Look at here, 42 and minus 6. 42 minus 6 is equal to 36. So this is plus 36. This one, since we are getting negative sign, should multiply with minus to make it positive. Finally, our getting lambda cube minus 11 lambda square plus 36 lambda and minus 36 is equal to 0. This is your cubic equation in terms of lambda. We have to factorize this one. Also, you can use a calculator for this. I'll be going for the next page. So by trial and error method, I am applying trial and error method. I am taking lambda value is 1. I am not satisfied. So minus 1 also. So if you take lambda value 2, you will get the solution of this. So take lambda value 2 and apply the synthetic division method. Here we have to write their coefficients. 1 minus 11, 36 minus 36. This method, if you don't want to do it, you can just find out the roots using the calculator. Here 1 plus 0 is, sorry, here I wrote by mistake 2. It is 1 only. 2 ones are 2. This is minus 9. Minus 9 2s are plus 18. Minus 18 here. 18 here. 18 2s are 36. This is one of the verification that the last term must be cancelled. You get the coefficients of second degree. Plus 18 is equal to 0. Now find out their factors. Simply lambda square. 9 lambda can be written as minus 6 lambda minus 3 lambda. 6 3 is 18 are the possible factors. Plus 18 is equal to 0. If you take lambda common, you get lambda minus 6. If you take minus 3 common, you get lambda minus 6 is equal to 0. Finally, eigenvalues I want to write. Eigenvalues. Since the order of this matrix is 3 rows and 3 columns, our eigenvalues are lambda is equal to, first I am getting 2, then I am getting 3, then I am getting 6, which means it is called non-repeated eigenvalues. Now we start our work to find out their eigenvectors. Case number 1. When lambda is equals to 2, and we have to take their corresponding vector will be capital X1, that is called like that. X1, X2, X3. So there after this one, we have to put this lambda value 2 here. We have to put our lambda value is 2 here in this equation. 3 minus lambda minus 1 plus. Here if you put lambda value is 2. Okay. Please do not depend upon me. You have to do this problem by own. खुद से भी एक बार करके देख लो जी. So 3 minus 2 is 1. Minus 1 plus 1. This is -1. This is 3. This is only the change in the diagonal elements only. There is a change in a diagonal element only. You can verify lambda value 2 means 5 minus 2 is 3. 3 minus 3 is 3. This is 3 minus 2 is 1. Yes, correct. And vector, what we are taking, that we have to write it here. x1, x2, x3 is equal to, we have to equate always with 0, 0, 0. Now you will get the equations. Now you see here, first row and third row are called beautiful rows. I repeat once again, first row and third row are called beautiful rows. So it means do not solve 1 and 3. If you solve it, you will get your answer is 0, 0. Okay. Do not solve 1 and 3. Solve any two. 1x1 minus 1x2 plus 1x3 is equal to 0 is your first equation I am considering. Now second equation is minus x1 plus 3x2 minus x3 is equal to 0 is your second equation. You have to solve these two equations by cross multiplication method. x1 by minus x2 by x3 by x1 means neglecting x1, you will get determinant of rest of the elements minus into minus plus 1 1 is 1 minus 3 1 is 3. Now x2 neglecting x2 minus 1 is minus and minus into minus plus 1. x3 we have to neglect 3 1 is 3 minus 1 1 is 1. So x1 by minus 2, x2 by minus x2 by plus 1 minus 1 cancel 0 and x3 by 2. 2 1s are 2 1s are it is cancelled and minus if you multiply with the denominator you will get 0 only. Finally, I am getting my first eigenvector is minus 1 0 plus 1. This is our one possible eigenvector. Okay. Now moving to the next. To find out the second eigenvector. Now what we have to take, case number 2 we have to take. That is case number 2. When lambda is equal to 3. When lambda is equal to 3. So if you simplify, I think we are not getting the sufficient time to do it. Let us do it. Lambda is equal to 3 if you take, to get your vector will be 0, minus 1, plus 1, and here it is minus 1, and 2, minus 1, 1, minus 1, 0, and the corresponding vector we are taking as x1, x2, x3. If you want to mention, you can mention, otherwise, anyhow we are doing here 0, 0, 0. So you should not get any beautiful equation. So we can solve any two equations. Choice is yours. 0x1 minus x2 plus x3 is equal to 0. This we are considering the first equation. Minus x1 plus 2x2 minus x3 is equal to 0. I think you can solve the equation. Please, I don't have the sufficient time. I'm sorry for this one. I'm writing the x2 values because already I have shown the method. Okay. So it's a 1, 1, 1. You can solve it later on. If you don't get, you'll tell me. Third case, you have to take lambda is equal to 6 and the corresponding eigenvector for lambda is equal to 6 will be capital X3 is equal to 1 minus 2 plus 2. Okay. Now for each eigenvector, you have to find out normalized eigenvector. So that one I am using the short form. normalized eigenvector is equals to, yeah, this is ऐसा करना है देखिए. I'll tell you the rule. Where is that space? Okay. Suppose ABC is your vector. For this one, if you want to find out normalized eigenvector, the formula will be A by under root A square plus B square plus C square. B by under root A square plus B square plus C square. C by under root A square plus B square plus C square. So the work will be done here directly. Minus 1 by under root of A square plus B square plus C square is root 2 only. And this is 0 only. This is 1 by root 2. For this one also, normalized eigenvector will be, what you will get? Tell me. 1 by root 3. 1 by root 3. 1 by root 3. For this one, normalized eigenvector will be 1 by root 6 minus 2 by root 6 and 1 by root 6. After getting this vector, we have to form the matrix P. That is will be taken in the next page. So form the matrix P using the normalized eigenvector. Okay, we get it. Our matrix P will be P is equals to, this is the normalized eigenvector से बन रहा है. First vector का, this is minus 1 by root 2, 0, plus 1 by root. This is 1 by root 3. This is also 1 by root 3. Also 1 by root 3. And this is 1 by root 6. Okay. This is minus 2 by root 6. This is 1 by root 6. This is our value of P. After getting the value of P, we have to find out its transpose. That work you can do it. Just to simply row make it as a column. This is first row, we should write in a column. Minus 1 by root 2, 1 by root 3, 1 by root 6. Row as a column. Again, row as a column. After getting P transpose, now our main work will start. That is, if you want to get the value of diagonal matrix, your verification will be P transpose and the vector A and P. If you multiply these three matrices, P transpose is here, P is here, and A is our given matrix. Your final answer should be like that. 2, 0, 0, 0, 3, 0, 0, 0, 6. This is your final matrix. Okay. After that, canonical form. Matrix multiplication method is required to apply this one. Directly आप normal calculator से करे तो ही आता, otherwise you will not get. Then we will get the canonical form. Canonical form. Canonical form formula is Y transpose into diagonal matrix what I am getting into Y, where capital Y is equal to like that, Y1, Y2, Y3. For this also I will give you the shortcut. Y transpose means it will be like that. इसको कॉलम बना दे, कॉलम रो बना दे. Y1, Y2, Y3 into the diagonal matrix what I am getting here is 2, 0, 0, 0, 3, 0, 0, 0, 6 into the matrix Y here. Again the matrix Y is Y1, Y2, Y3. But it will take a lot of time when you are multiplying this one. The shortcut will be C. 2, y1 स्क्वायर, जो भी आपके अगेन वैल्यूज आए ना यहाँ पर रखो y1 के साथ, 2y1 स्क्वायर प्लस 3y2 स्क्वायर प्लस 6y3 स्क्वायर, दिस इज कॉल्ड कैनोनिकल फॉर्म, दिस इज कॉल्ड कैनोनिकल फॉर्म ऑफ द मैट्रिक्स, कैनोनिकल फॉर्म शॉर्टकट में भी लिख सकते हैं। नाउ नेक्स्ट यू कैन सी कैनोनिकल फॉर्म में कन्वर्ट हो गया। नाउ रैंक, इंडेक्स एंड सिग्नेचर एंड नेचर, सो लुक एट रैंक, rank denoted by small r. So in this diagonal matrix, how many non-zero rows are there? 3. Rank is 3. Index denoted by capital S. Number of positive square terms in this canonical form. So there are 3 positive square terms. Now signature. Signature is 2s minus r. 2 into s value is 3 minus r value is 3. 3 to the 6 minus 3, answer is 3. So signature. Now finally we have nature. Nature of this canonical form. Nature means, you see, we are getting all the 3 terms. All the 3 terms are positive. So the nature is positive definite. अगर एक नेगेटिव आता तो पॉजिटिव सेमी डेफिनाइट, अगर तीनों नेगेटिव आते तो नेगेटिव डेफिनाइट। ओके, तो ये रहता नेचर। अच्छा अच्छा, आप कुछ भी लिखो उसमें, डेफिनाइट इंडेफिनाइट, दैट इज नॉट प्रॉब्लम, इट विल बी एक्सेप्टेड। अच्छा, यहाँ पर एक क्वेश्चन अराइज हो रहा, जो कोई ने पूछे, सर ये ऑर्थोगोनल ट्रांसफॉर्मेशन कहाँ पर यूज करें? ये क्वेश्चन अराइज होता है, ऑर्थोगोनल ट्रांसफॉर्मेशन को अपन कहाँ पर यूज करें? यू कैन सी, इफ यू मल्टीप्लाई दीज टू मैट्रिसेस x1 x2, ये कंडीशन, ऑर्थोगोनल ट्रांसफॉर्मेशन का मतलब ये, x1 का ट्रांसपोज x2 के साथ 0 होना चाहिए, x2 का ट्रांसपोज x3 के साथ 0 होना चाहिए, and the transpose of x3 along with x2 must be 0. Order may be changed, मतलब x2 transpose into x1 भी हो सकता हो। मैं एक का वेरिफिकेशन बता देता हूँ। What x1 we are getting? -1 0 1. What x2 we are getting? This is just for verification that you are doing absolutely correct. You will get the full marks. And if this question is given quadratic form to canonical form and all these conditions is asking, you will be lucky for this one. You will get this question for 12 marks. For autonomous student, I'm asking 1 minus 2 plus 1. Let me check this condition. x1 transpose with x2. x1 transpose means row we can make it as a column, -1 0 plus 1 into 1 1 1. First row first column method. -1 into 1 is -1. 0 into anything is 0. 1 1 the 1 plus 1 minus. Are you getting 0? Yes. Similarly, x2 transpose with x3. यहीं पे करके बता दो। 1 1 1 with x3. 1 minus 2 plus 1. Look at that. 1 1 is 1. Minus 2 plus 1. So again 0. So it means if you take any matrix and to apply the transpose with any other matrix, you will get your answer will be 0. If this condition satisfied, means your eigen values are orthogonal to each other. अगर आपका मैट्रिक्स ऑर्थोगोनल हो रहा, कंडीशन सेटिस्फाई हो रहा, इसका मतलब आप जो भी प्रोसेस कर रहे हैं वो सही है। आखिरी में यहाँ पर एक वेरिफिकेशन रहता, P ट्रांसपोज, ये मैट्रिक्स A which is given in our question, this not given our question, this one, this matrix A, this one, what we are getting from quadratic form. तो ये एक क्वेश्चन नहीं है, देखिए जो मैं आज कवर करा, एक छोटा क्वेश्चन हो सकता है 2 मार्क्स के लिए, क्वाड्रेटिक फॉर्म टू सिमेट्रिक फॉर्म, ये यहाँ पे इसका खत्म हो गया, क्वाड्रेटिक फॉर्म टू सिमेट्रिक फॉर्म। और दूसरा एक पॉसिबल क्वेश्चन आ सकता है इसमें से, आइगन वैल्यूज, ये आइगन वैल्यूज आ गए 2 3 6, तीसरा एक पॉसिबल क्वेश्चन हो सकता है इसमें से आइगन वैल्यूज एंड करस्पॉन्डिंग आइगन वेक्टर। सो आइगन वेक्टर x1 x2 x3। कभी कभी क्वेश्चन ऐसा भी आता, प्रूव दैट द आइगन वेक्टर्स, if anybody write anything on the screen I will remove from the class. Okay, so eigen values, eigen vectors prove that the eigen vectors are orthogonal। ऐसा भी क्वेश्चन आ सकता है, ट्रांसफॉर्मेशन की कंडीशन चेक कर लेते। फाइनली आपको जो आज जो मैं कराया ये नॉन रिपीटेड आइगन वैल्यूज है। ओके, अगर रिपीटेड हो रहे तो फिर अलग हो जाता क्वेश्चन ऑर्थोगोनल ट्रांसफॉर्मेशन से। दिस इज कॉल्ड कैनोनिकल फॉर्म। दिस इज ऑल्सो इंपॉर्टेंट, कैनोनिकल फॉर्म। मैट्रिक्स से कैनोनिकल फॉर्म कैसा फाइंड आउट करें, एंड रैंक, इंडेक्स एंड सिग्नेचर। इस शॉर्टर डेफिनेशन भी हो सकता है आपको इंडेक्स से बोल, नंबर ऑफ पॉजिटिव स्क्वायर टर्म्स इन, यहाँ पे लिखूं क्या, नंबर ऑफ पॉजिटिव स्क्वायर टर्म्स इन कैनोनिकल फॉर्म। ये तो आपको पता है, नंबर ऑफ नॉन जीरो रोज इन डी, नॉन जीरो रोज इन डायगोनल मैट्रिक्स डी लिख दिया। इसके लिए तो डायरेक्ट फॉर्मूला दे, ये पॉजिटिव डेफिनेट, बिकॉज यहाँ रीजन क्या है, ऑल आइगन वैल्यूज आर पॉजिटिव। दो पॉजिटिव एक नेगेटिव है तो सेम ही होता, तीनों नेगेटिव है तो इंडेफिनेट भी लिख सकते हैं। So this is the concept of quadratic form to canonical form. I hope you understand. If we'll get the time, I'll go for one more question, that is when eigen values are repeated. Repeated case में आपको eigen vectors को कैसा find out करना रहता, जैसे यहाँ पर case 1 case 2 case 3 हो गया, they may not be in the case 2 case 3 here, that concept I'll do it, ये आप लोग कर लो, and I hope you understand the class session. So thank you for your cooperation. The class will be ending.
Excuse me, sir.
Yes, बोलिए
Sir,
बोलिए, कौन, हेलो,
excuse me, sir.
हाँ बोलिए।
Sir, we can find this eigenvalues by calculator, or we have to write this step lambda equals to 2, this
No,
method.
calculator also accepted.
Okay.
It is not compulsory to go for synthetic division method. Very good question. You can do it by using the calculator. Our intention to get the eigen value. कैसा कर रहे हैं वो important नहीं है।
Okay, sir.
Yes.
And we have to prove that conditions.
No, that is your
Last-
satisfaction. That is your satisfaction. That is your verification. To satisfy that you are doing
Okay.
correct. वो आपके satisfaction के लिए है बस।
Okay, sir.
Okay, thank you.